Welcome back to the explainer. Listen, mastering trigonometry double angle formula is absolutely essential for your Cambridge Mathematics AS and A-level success. We are talking specifically about syllabus code 9709 here. And you might be wondering, why focus so heavily on this one specific area? Well, because this topic appears in virtually every single examination series. It's literally unavoidable. You cannot hide from it, and honestly, you really shouldn't want to. Once you actually understand the underlying mechanics, these questions become a highly predictable, incredibly reliable source of marks. It's like having the cheat code to the exam. So today, we're going to program your brain for maximum efficiency. We are going to build automated, bulletproof patterns for these common question types so you can tackle them exactly like an engineer would. No panic, just a pure systematic approach. But right off the bat, here is the massive question we absolutely have to address. Why do multi-stage trigonometry questions cost students so many method marks? You know the feeling, right? You've sat there, you've memorized sine 2 theta, you know the 3 different versions of cosine 2 theta, you've done the flashcards, yet you get your mock paper back and the page is just covered in red ink. It's frustrating. This is a universal pain point for so many A-level students. Well, today, I'm giving you an exclusive, behind-the-scenes look directly into the examiner's blueprint so you can finally stop losing these critical marks. We are going to completely bridge the gap between just knowing the math in your head and actually scoring the A-star grade on paper. So here's our roadmap for today's explainer. First, we'll look at the challenge. Second, the strategy reveal. Third, the transformation. Fourth, our interactive workshop. And finally, we'll lock it all in with the final system. Let's dive into Act 1. The challenge, the tale of two candidates. Okay, let's set the stage with a real Cambridge mathematics past paper scenario. Imagine a complex tan 2 theta equation. We typically see two very specific candidate profiles when marking these. Let's look at our first candidate, Alex. Now, Alex overloads the page with raw mathematics facts. Alex sees a double angle and immediately panics, writing down literally every version of the cosine 2 theta identity in the margins without stopping to actually think about which one helps solve this specific equation. There is zero structured analysis. It's just a complete brain dump. It's messy, it's totally disorganized, and to be blunt, examiners really dislike it because they simply cannot follow the logic. You're making them hunt for the right answer, which is never a good idea. Then, on the flip side, we have Sam. Now, Sam rushes the process. Sam completely misses the crucial command word requirements. The question might explicitly say, show that, or hence solve, but Sam is in a hurry and skips all the crucial algebraic substitution steps, jumping straight to the final roots using a calculator. Sam genuinely thinks they just saved 3 minutes of exam time. But you know what the examiner sees? They see a skipped process, an unproven leap of logic, and they immediately give 0 method marks. Both of these approaches, raw memorization and rushing, lead straight to a page full of red pen marks. So how do we fix this? That brings us to Section 2, the strategy reveal. Decoding the examiner's mind. There is a stark, fundamental contrast between what you think the exam is testing versus the actual reality. Student expectation typically focuses on superficial breadth and just finding that final magic number at the bottom of the page. You think the final answer is all that really matters. But examiner reality? It heavily prioritizes analytical depth and logical, structured reasoning. The Cambridge syllabus explicitly emphasizes that top-performing candidates exhibit connected conceptual understanding. They do not just want the destination. They desperately want to see the map you drew to get there. It's about the journey of your logic. Before we continue, subscribe to our YouTube channel, Ace the Exams, at @acetheexams_IGCS, to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, let's dive into the absolute core of this explainer, the method marks strategy. The definition here is absolutely crucial to understand. Method marks, which are often denoted as M marks on your Cambridge mark schemes, are awarded explicitly for demonstrating a logical process, systematic processing, and evidence-based reasoning, rather than just the final answer. Let me put that into perspective. If you logically choose and write down the correct double angle substitution, even if you completely mess up a simple arithmetic addition 3 lines later, you still securely bank that method mark. The process itself is exactly what examiners are grading. You are quite literally building a watertight argument using algebra. If the argument structure is sound, you get rewarded. So to absolutely guarantee you capture those method marks every single time, we use what I like to call the 5-part procedural framework. You can easily remember this with the acronym IAEVP. Now, you might have heard of the Peel framework used in essay subjects like history or English, right? Point, evidence, explanation, link. Well, this is that exact same concept, but specifically adapted for the analytical depth required in Cambridge mathematics. Let's break it down. Step 1, identify key elements. Look closely at the equation. Are the angles mixed? Is one term a single theta and the other a double angle, 2 theta? You have to diagnose the problem first. Step 2, apply relevant principles. This is where you actively choose the right identity. If the rest of your equation is heavily in terms of sign, you strategically choose the specific cosine double angle identity that only uses sine. Step 3, execute analysis. Do the algebra, expand your brackets, factorize the quadratic, simplify the terms, show your step-by-step working clearly down the page. Step 4, verify results. This is where so many students drop marks. Check your calculated roots against the given domain in the question. Reject any invalid solutions explicitly. Step 5, present format. State your final answers clearly in the exact format requested. Did they ask for radians, degrees, exact surd form, 3 significant figures? This framework is your ultimate mental checklist for mathematical reasoning. Let's see this in action in Section 3, the transformation, rebuilding the answer. Now we get to watch those painful red pen marks transform into beautiful green check marks. We are taking Alex and Sam's flawed answers from earlier and entirely rebuilding them using our new IEVVP framework. Remember Alex? Alex's before was just vague fact dumping, but after applying the method mark strategy, Alex now uses a highly structured execution of steps 1 through 3. Instead of scribbling all 3 cosine double angle identities on the side of the page, Alex now explicitly writes, since the equation contains sine theta, use cosine 2 theta equals 1 minus 2 sine squared theta. Boom, the logic is declared, the examiner smiles, and the method mark is securely in the bag. And what about Sam? Sam's before was rushed and completely missed the context of the question. The after? Verified and perfectly presented. Sam now writes out the full quadratic formula steps before jumping to the roots, and crucially, actively writes the word reject next to a root that falls outside the given 0 to 360-degree domain. That single verification step in the working grabs the final accuracy marks that Sam was previously just throwing away. It's a complete game changer. Now I want you to actively apply this right now. We are initiating a 60-second rewrite challenge. I want you to mentally pause and think about exactly how you would structure a response to a complex tan double angle question using the IAEVP framework we just covered. How would you lay it out on the page? Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Welcome back. Let's move into Section 4, the interactive workshop. It is time to test your analytical depth. It's time to take these automated patterns we've discussed and apply them directly. Challenge 1 is the data scan. You have 60 seconds on the clock. Imagine a highly complex data set right here on the screen showing a trigonometric function modeling a real-world scenario. Let's say it's modeling tidal heights, and it involves a tricky double angle. Your job here isn't to just blindly plug in numbers on your calculator. It's to extract the core trends of the model. You must identify the amplitude, figure out the period change directly caused by that double angle, and spot the principal phase shift. That is exactly what extracting core trends means in high-level 9709 mathematics. You have to be able to see the physical geometry behind the abstract algebra. All right, time is up on that one. Let's smoothly transition over to Challenge 2, find the flaw. For this one, you are looking for the top 3 mistakes pulled directly from the actual Cambridge Principal Examiner reports. These aren't just guesses. These are the exact documented reasons thousands of incredibly smart candidates drop a full grade boundary every single year. Let's see if you can anticipate exactly what they are before I reveal them. Okay, here is the big reveal. Let's really unpack these principal examiner warnings together. First up, answers are far too vague. Examiners demand specific details. What does that actually mean? Well, in trigonometry, vague means skipping the algebraic substitution step entirely. You must explicitly state the identity you are subbing in. Don't make the examiner guess how you got from line 2 to line 3. Second, candidates forget to check formatting and presentation of working. This is huge. If a question explicitly says, leave your answer in exact value, and you give a long decimal, you instantly lose the mark. No arguments. Furthermore, if you write your working all over the margins where the logic literally cannot be followed top to bottom, you lose the method mark. Third, final answers are generic and not specific to the given context. Listen, if the double angle is modeling a real physical problem where time must logically be a positive value, and you don't explicitly reject the negative time root, you are giving a generic mathematical answer, not a context-specific one.
These 3 mistakes absolutely destroy method marks, so banish them from your exams today. Let's lock this knowledge in with Challenge 3, the 30-second speed writing challenge. If you were asked in an exam to explain exactly why a particular route is invalid in a modeled scenario, you have 30 seconds to write one perfect, context-specific sentence applying step 4 of our framework, verify results. Ready? Go. It should sound a little something like this. Since data represents an acute angle in a physical triangle, the negative root of cosine theta must be rejected. Do you see how specific that is? That is a perfect, examiner-pleasing sentence that guarantees the mark. Let's bring it all together in Section 5, the final system, achieving evaluative mastery.
We are now completely transitioning from basic methodology to the high-tier elite evaluative thinking that is absolutely required for maximum marks. This progression map you see here is your literal ladder to success. Down at the bottom, we have the descriptive level. The characteristics here are vague, generic equations, and just throwing isolated facts at the page. This yields very low marks. This is exactly where Alex started out. Next step up is the analytical level. Characteristics here include systematic processing, very clear working, and actually using the IEVP framework. This yields high marks. Honestly, you'll get a solid B or an A right here. But right at the very top is the evaluative level. The characteristics of an evaluative student: they question assumptions, they identify the limitations of a model, they offer alternative interpretations, and every single answer is fully context-linked. This is what yields maximum top-in-the-world marks. In a 9709 paper, this means recognizing exactly when an identity creates extraneous, fake solutions, or brilliantly justifying why a mathematical model completely breaks down outside a specific domain. That, my friends, is true evaluative mastery.
So, to fully recap the complete mathematics answering system, here are your 3 absolute rules for top marks. Rule 1, command word decoding. You must always know the strict difference between exact value, show that, and hence. They demand completely different things. Rule 2, procedural framework application. Consistently use our 5-step IAEVP structure to absolutely guarantee those method marks. Rule 3, time management matrix. Please, do not spend 15 minutes agonizing over a simple 3-mark double-angle question. Move systematically and trust your training. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos.
Before we wrap up, I want to leave you with this incredibly profound quote directly from the Principal Examiner Alert. The classic mistake is providing generic answers. Always link every point to the given scenario. You have to internalize this. Never forget that mathematics at the A level is not just about moving abstract numbers around a page, it is fundamentally about logical modeling and highly precise communication. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to at acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here. But as you close this out, just consider this final thought. If applying a simple double-angle formula can entirely change the validity of a mathematical model in the real world, what other hidden assumptions are you currently making in your daily problem solving? Keep analyzing, keep verifying, and I will see you in the next explainer.